More and more of your newer computers these days are coming with chips inside of them that are 64-bit processors, and on top of them we're running 64-bit operating systems. But what is the real difference between a 32-bit technology and a 64-bit technology? There's a number of differences. The primary difference is the amount of space, the width of the registers or the counters that are used in the CPU. In a 32-bit CPU, you've got a 32-bit register. In a 64-bit CPU, it's a 64-bit register. And there are many different registers inside of these CPUs. There's an address register, there are integer registers, there are other registers as well. The wider the register, the more you can do with it, the larger the calculations can be, and you can move more data as well. If you're pulling in 64 bits at a time and you're able to work with it, you're pulling in and sending out twice as much data, if you want to look at it that way. The buses on the computers are designed for these larger widths. A 64-bit data bus, for instance, obviously is moving twice as much as a 32-bit data bus. In fact, we have data buses that are 64 bits, but processors that are only 32. It's just another method of sending data back and forth. So you may have the CPU registers themselves as 64-bit, and you've got another bus sizes out on the external to the chip that don't necessarily match the CPU architecture. So don't be thrown by that when you're looking at specifications for a computer that show the size of the bus versus the size of the registers inside of your CPU. When you're on a 64-bit operating system and you're using a 64-bit CPU inside of your computer, obviously, you have to make sure the software that you're using is designed to work in a 64-bit environment. This is really the stumbling block we run into when we're trying to implement 64-bit architectures these days. You have to make sure all of those things match up, that you have a 64-bit processor, a 64-bit operating system, and your drivers, all of the things that you need to run hardware, and the software, the applications that you're going to use will work properly on a 64-bit operating system. Generally, your applications will run just fine, but if there's an app that uses a specific driver, it needs to integrate with the operating system in a very particular way, then it has to be 64-bit aware or it's not going to work. You can't simply take something created on a 32-bit architecture that works at that level and simply plop it on top of 64-bit and expect that to work. So you have to do a little more legwork if you're going to run 64-bit. You have to make sure every application that you're going to use, and even think into the future of the applications that you may need later, are able to take advantage of a 64-bit operating system. It used to be when we were buying a computer for the first time, we would try to buy the computer that was fastest. And in the past, we always looked at CPU speed as being able to be the fastest thing. We looked at how many megahertz, and these days, how many gigahertz, how many cycles per second can the CPU inside of this device go. And usually that was our stumbling block. That was our limiting factor, that if we wanted to go faster, we needed a faster CPU. That was the best thing to do. But these days, the actual speed of our computer, there's a lot of different components working together. We've got clock speed, we've got the architecture of the system, we've got the speed of the bus, we've got caches that are on the CPU, we have the capabilities of the operating system. There's so many different factors to take into account that we can't just look at the speed of the CPU anymore. We do need to look at the cache memory. We do need to understand the type of bus that's running underneath and the speed of the bus that's running underneath to get a real understanding of the actual speed. We're seeing these days that manufacturers are not using clock cycles so much anymore as the primary perspective, the primary thing that you would look at to determine the speed of a system. They're now looking at the different capabilities of a computer. We're now buying computers today to perform different functions. And the first question usually is, what do you want to do with it? Are you just looking to surf? Are you reading books? Are you producing videos? All of those things will mean different components might need to be faster or slower, not just the CPU, but all of those other associated components within the computer itself. Unfortunately, there's not just one number that we could look at to determine the speed or the usefulness of a computer. It's almost impossible to come up with something like that because some benchmarks might test video speed and the ability to do video more than other benchmarks. But if I'm buying a computer just to do some surfing on the internet, video may not be the biggest component. I might want to weight that particular part of my system a little bit lower. It's not that important for me. But if I'm doing video editing, the video capabilities are extremely important to me. So not only is there not one benchmark that we can use, it's almost impossible to come up with one benchmark because everybody has different requirements for their systems. My suggestion is for people to look at every component of the computer and try to find the one that matches what you're trying to do with it. Sometimes that may require you do some research and ask some people what they think about those different capabilities. But in the end, you need to, of course, consider everything in there before you start buying systems. Let's review what we've learned on CPU technologies. Our first question is, what kind of memory is very fast and often included right on the CPU itself? Well, we looked at the actual picture of some of that, and that was our cache memory. The second question is, what CPU technology virtualizes a single CPU into two virtual processors to share the workload between them? Well, if you have one processor, that's not dual core, that's a single core processor. It's really taking advantage of this hyper-threading technology, or HTT. You'll see it abbreviated as. And lastly, what is an important consideration of 64-bit systems? Obviously, we're going to need to look at the operating system, the drivers, and the software that we're going to use to make sure that it's going to work properly on a 64-bit system and that all of those will work together without a problem. Well, that covers what we needed to know for this section 1.4. We've gone through CPU types and hyper-threading and multiple cores and caching and 3264 bits and speeds and all of those things in between. If you'd like to watch any of our other free A+ videos, you'd like to send me a message, much more, you can visit our website at freeaplus.com.